Hello, today we're going to talk about Chapter 7, Lesson 7, and that is on geometric sequences. So you will find this information on page 438 through 443. So today there are three types of problems that you're going to see today. The first is just what type of sequence is it. So you're going to be given a list of 4 or 5 numbers, and you're going to have to determine what type of sequence it is. Well, there's two types. There's arithmetic or geometric. All right. Essentially, this is linear and this is exponential. Okay, so if you recall, an arithmetic sequence is generated by adding or subtracting to find the next term. All right, so I may add 3 to get the next term and add 3 again to get the term after that and add 3 to get the term after that. All right, so essentially that was the slope, and remember we talked about the shortcut for addition was multiplication. So if my slope was y equals 3x, I'm really adding, so if I say 3 times 2, I've really added 3 twice. So this is the linear piece that we learned earlier in the year. Now if it's geometric, the sequence is generated by multiplication. Okay, so I might be multiplying by 5 a whole bunch of times, or multiplying by -2, or multiplying by 1/2. And then the pro tip today, if you see division, well, we're dividing by 4 to get the next terms. Remember, I want you to think fraction, and you're not dividing by 4, you're going to be multiplying by 1/4. Okay, because this common ratio that you'll see is going to be our R value in our formula, and we'll see that over here, and it needs to be multiplication. So again, if you see division, I need you to think fraction. All right, so finding the next 3 terms is the kind of the second part to this lesson. This is probably the easiest. Once you figure out the common ratio in the geometric sequence, you're just going to be multiplying that number by the previous terms to find the next. So you'll do it 3 times. All right, and then where we get a little more abstract is finding the nth term. We're going to be using the formula an. So the nth term, that's all that sub n means, is it's the nth term. All right, and that is the first term. That's what a sub 1 means, is this is the first term in the sequence. We'll have to know that. Times the common ratio, so whatever we figure out from the sequence, being raised to the n minus 1 power. All right, I'll explain that more when we get to the story problem about why it's n minus 1. And it has something to do with this being our first term. We're not multiplying the common ratio by it. So to get the second term, it would be 2 minus 1. We're using the ratio 1 time in the second term. But I'll explain that more in the story problem. All right, again, A1's the first term in the sequence, and R is the common ratio, what we're multiplying each term to get the next term. Okay, so again, this is kind of an overlay of what you're going to be working on these problems. All right, so all I need you to do in this video is to kind of follow along and copy each example down. All right, so here's example 1. We're going to do 2 different types because I want to show you an arithmetic sequence and then a geometric sequence. If we don't see anything going on, if we can't find a common addition, subtraction, or a common multiplication, then the answer could be neither. All right, so we have our sequence, and we want to look to see if we're going to be adding or subtracting to get the next term. In this one, it looks like addition, but we can check by simply subtracting the second term from the first and the third from the second. So it looks like this. 8 minus 0 is 8. 16 minus 8 is 8. 24 minus 16 is 8. And then 32 minus 24 is 8. All right, so we see that this has a common addition to get from one term to the next. 0 plus 8 is 8. 8 plus 8 is 16. 16 plus 8 is 24. So this has a common addition. So this is an arithmetic sequence, and that common difference is 8. All right, so pretty basic. Looking for the pattern, identifying whether it's addition, subtraction, which is a common difference, so that's arithmetic, or as you'll see in the next problem, if it has a common ratio. All right, so here's our next sequence. All right, so we kind of write it out, and we're looking, maybe you think it's addition, so 48, or to get from 64 to 40, I'd be subtracting 16. 48 to 36 would be 12, so there's definitely not a common difference. Let's check if there's a common ratio. So we kind of do the same thing. We're going to take the second term and divide it by the first. So 48 over 64 reduces to 3/4. 36 divided by 48 also reduces to 3/4. And yeah, if you do the last one, 27 divided by 36 gives us 3/4. So if we multiply each term by 3/4, we will get the next term in the sequence. So this is geometric because it has a common ratio. Again, common ratio is a vocabulary word to say what we're multiplying by to get the next term. All right, and we find that by, if you can't see it, which I didn't see 3/4. I knew it was multiplication, but I didn't know what. I would have had to divide and then figure out, reduce that fraction, okay? Or even just use a calculator, I guess. All right, so that's essentially how example 1 is going to break down. So let's take a look at what example 2 problems are going to look like. All right, so again, we're still given a sequence. It's telling us geometric, so we should be dividing each previous term to figure out what that common ratio is. So kind of write it out and check. -8 divided by 1 is -8. 64 divided by -8 is -8. And -512 divided by +64 is -8. So we found our common ratio. All right, it's -8. And then all we have to do is take our sequence. So I think the last one on here was 512. Yeah, so we're going to multiply -512 by -8. Two negatives make a positive, so that's 4,096. And we're going to multiply this guy by -8, and we get -32,768. And then one more time, this is the first term they wanted us to find, this is the second term, and now the third term, multiplying by -8 to get 262,144. All right? And I mean, you can formally write out your answer, or you can just write these three. I'm fine with that. The real work is in finding the common ratio. Okay? And then finding the nth term, there's kind of here's our formula, and they have it color coded. So, and I've already explained this in that first slide, where A1 is our first term, R is the common ratio, and we're going to raise that R, not the A1, just the R. Whoops, sorry. Let me go back. We're going to raise that R to the n-1 power. So essentially, if we want the fourth term, we're going to raise R to the third power. And you'll see that better why it's n-1 in the last example. All right, but let's just try to take a problem and work it into this. So here's our sequence. 1, -2, 4, -8. The first term of the sequence is 1. We see that, so we know A1 already, which is nice. Now we have to find the common ratio. I made that green because that's the way it is in the formula. So 1, -2, 4, and 8. If we work backwards, -2 divided by 1 is -2. 4 divided by -2 is -2, and -8 divided by 4 is -2. So we have a common ratio of -2, and that's in blue because that's the way it was in the formula on the previous slide. So now it just comes down to me taking these numbers and putting them into the formula. That's it. Bam. So it's 1 times -2 to the n-1 power, and you'd probably formally write that just like this. So again, taking your first term, taking your common ratio, and raising it to the n-1 power. I don't want you to memorize that it's n-1, but I mean, if you have to, you have to. It's n-1. That's about the only trick here. Otherwise, you're just putting numbers into that formula. Now I'm going to try my best to explain this n-1 on the next problem. Okay? So, we have an ice sculpture that's 50 pounds, and it's melting at a rate in which 80% of its weight remains each hour. They could have made this a little trickier and said it's losing 20%, but then you'd have to calculate what's left, which is 80. It's kind of like a decay problem. That 1 minus 0.2 is 0.8 or 80%. So we're going to draw a graph to represent how many pounds of the sculpture are left after each hour. All right, so I kind of set up a table here, and if we think of it this way, okay, as time 0, this is really our first term, but as time 0 being our initial weight of 50 pounds, right? That's our A1 value essentially. And then after 1 hour, we're going to multiply that 50 by 0.8 to get 40 pounds. 50 times 0.8 is 40 pounds. Now, if we think of it after 2 hours, we're saying this 50 times 0.8, which was 40, right? This is 40. If we multiply it by 0.8 again, we get to 32. All right, so essentially, I've used this common ratio twice. Whoops. And then we're doing the same thing here. So 50 times 0.8 times 0.8 is 32. If we multiply by 0.8 again, we get to 25.6. And then the same idea again. The 50 times 0.8 times 0.8 times 0.8, that's the 25.6. Multiply that by 0.8 again, and we get to 20.5. I believe that was 20.48. I think I had to round that one. All right. Now, how does that look in our current nth term formula? Well, if we think of it this way, the same exact sequence where we're going to call the term 50 the first term, all right, and then an hour passes, so our second term is 40. We're now multiplying by 0.8 once. All right, so it's going to be, if we think of it here, the exponents work without an n minus 1. But if we think of it in terms of just numbers, notice that I'm using the 0.8 once. For the third term in the sequence, I'm using the 0.8 twice. Okay. For the fourth term, which is really 3 hours past since we've built our sculpture, I've used the 0.8 3 times. So this is where you get the kind of n minus 1 idea. 4 minus 1 is 3, 5 minus 1 is 4, and that's how we're building that formula. Okay, I kind of hope that helps get you to understand why it's n minus 1. So in a story problem, you might not be thinking of it that way. If you think of it this way, you'll be absolutely right. But if you're more of a, you want to write those sequences down in order, you may want to think of it this way. So as in term 1, and then using this r value once because it's the second term, twice because it's the third term, that n minus 1 idea. And then when we graph it, we simply just, ooh, they had one more point there, but that's okay. Plot your points. So at term 0, we're at 50. After 1 hour, we're at 40, and then 32, 25.6, and so on. So I hope this video helps. I have homework on the next slide for you to work on. It's right here. So please work on page 441, 1 through 31. And I will pick up with you guys on Wednesday. See you then.